up, Zone Squad? Today we're talking about parent functions and transformations. So what is a parent function? The way I always like to describe it is, think about your parents. You have your parents, and then they have you guys, and you guys are the transformation of your parents. Alright, so your parent function starts at 0, 0. And there's no transformations. We're going to talk about what transformations are. Alright, you have to know all the parent functions. By the time you get to Algebra 2 and all the upper math courses, you should know how every parent function looks like. Once you know how the parent function looks like, all you have to do is understand transformations and apply it to each transformation. The beauty about transformation is it's universal. So as long as you understand it one way, like let's say for example transformations through absolute values or quadratic formula or quadratic functions, then you can apply to all the other types of functions. But the most important part is you kind of have to know how they look like. So your parent functions kind of go over that. Linear, straight line, goes through 0, 0, slope is 1. All right, quadratic. Now I'll give you the equation, y equals x. Quadratic, happy face, at 0, 0 is your vertex, y equals x squared. Absolute value, so v, y equals absolute value of x. You see all these guys, they all go through 0, 0. Alright, radical, so it's going to be y equals square root of x. Sorry, 0, 0. You get that. Rational, we'll talk about this later. There are other videos, but we have asymptotes. Functions like that, so y equals 1 over x. And you also have trig, and you have x cubes, x cubed, cube function. Start at 0, 0, goes to 0, 0, looks like that. So these are all your parent functions. There's a lot more. There's a few trigs, sine, cosine, tangent. They're inverse functions. There's a lot more going on, but these are kind of the ones you have to know for sure. We'll throw in the other ones. We'll go more in depth within those videos. But you have to know these guys. So try to memorize this. Try to really understand it. If you don't know how it looks like, grab points until you get the idea of it. But I would really, make flashcards and start memorizing these guys, because once you understand transformations, which we're talking about right now, you just apply it pretty easily through each function. So let's talk about transformations. All right, transformation is going to have you have a, h, and a k value. All right, some functions add a b value. But we're just going to kind of stick with the h and k. So a is going to represent vertical stretch or shrink, stretch or compression. All right, your h value stands for horizontal, so it's your horizontal shift, left and right. I'm going to put opposite, because we're going to use that a lot. And then K represents your vertical shift. Up and down. Okay? So you have to know where they're at. So let's just talk, for example, quadratics. You're going to have ax minus h squared plus k. So we need to figure out where they're located. So the a value is the guy on the outside multiplied. H value is the one associated with the x value, which is either being subtracted or added to the x value, usually inside the squared or the square root or the cubed or the absolute value. The k is the guy on the outside that's being added or subtracted to this whole function here. All right? You have to understand where they're all located. Once you know that, you're going to know the transformation that's occurring. So for example, that's it. And then we have 2x minus 1 squared plus 3. Another thing the a value does, if a is negative, it's a reflection. So the a value is negative, we're going to reflect this. So the graph is going to change, it's going to reflect. So let's say I give you this. Here's your a, here's your h, here's your k. So your a value is going to stretch it because it's getting bigger and bigger. So it's a vertical stretch. The minus 1 is going to shift it opposite, the right one. The k value is going to shift it up 3. So remember when I told you guys everything goes to 0, 0. Well, we start at 0, 0. Here's your happy face. We're going to take this vertex and shift it right 1 and up 3. All right, and then it's going to be vertically stretched. So we're going to stretch it, it's going to be a little more narrow. So look like that. It's just a quick sketch. Obviously, we can plug in points and solve for y and just put an input for x. But we at least want to use that 0, 0 and then start using that and shifting that around. Remember, every graph, if you look at your notes, they all go through 0, 0. So that's the one you want to move up, down, left, right, and then from there, plug in points to see how much is stretched. Maybe find the y-intercept, maybe find x-intercept. All right, it's a quick introduction to this, but really understand a, h, and k, look at it over and over and over, and figure out where they're located. All right, so that concludes our lesson for parent functions and transformations. We're going to do 3 examples. Just try your best on those. All right, your basic problem. Let's try this. Let's just do a quadratic again. Let's do negative 3x plus 1 squared minus 4. How do you know it's quadratic? Highest degree is 2. This is actually vertex form. I want you to describe what a, h, and k represent. All right, talk to me, write down what does the a value, the h value, the k value represent. I already told us a, h, and k. Look at your notes, write it down. Maybe about 30 seconds to a minute. Try your best, go. All right, so what does this 3 do? Negative and the 3. There's 2 parts. The negative is going to reflect. The 3 is going to vertically stretch it. Vertical stretch. This plus 1, this is where a lot of kids get confused. They think it's right 1, it's opposite, so left 1. And this minus 4 is down 4. So if you can start figuring this part out, this is going to help you limit errors when you start plugging in values. Because for example, your graph, after you graph it, you might have a happy face, but it's telling you that it should be reflected, it should be a sad face. So if you do a quick sketch, I go left 1, down 4. That's my vertex. Sad face, vertically stretched, your graph's going to look like that. All right, it's a quick sketch. Obviously, we can plug in points, maybe find the y-intercept. How do you find y-intercept? You let x equals 0 and solve. All right, check your answers. Make sure you got that correct. Your intermediate problem. Let's change the function, because we just talked about quadratic twice. Let's do y equals absolute value of x minus 3 plus 1. Write down the transformation and then do a quick sketch. Look at your parent function if you have to. I don't expect you to memorize all right now. So look at that to guide you through this. Try your best. Go. Okay. What's happening? Is there an a value? No. So there's no vertical stretch or shrink. Only thing there is going to be a translation. Up, down, left, right. This guy's your h value. So it's going to go right 3. Remember, it's opposite. This guy's your k value is going to go up 1. So all you have to do is your parent function, absolute value stands for v. Looks like a v here. You can go right 3, up 1, and draw that same v like that. So you transform the graph. So check your answers. Make sure you got this correct. Let's get ready for our advanced level problem. All right, our advanced problem. Y equals 2 square root x minus 3 plus 1. Explain the transformation. This 2 is actually times 2, not square root. talk about the transformation. I want you to do a quick sketch, look at your notes for the parent function, and try to do the best sketch for that. So we got 30 seconds a minute. Last problem, go. Alright, so this is your A value, so it's vertical stretch. This is going to be your H value, so right 3. This is your K value, which is going to be up 1. Okay, so right now we know that a radical function looks like that. I'm going to shift it, this 0, 0, right 3, up 1, vertical stretch, and a little bit more stretched out, and that's the one we get. So check your answers. Make sure you're not doing left 3, or down 1, or compressing it, or reflecting it. Make sure you guys are doing this correctly. So check your answers. Look at your notes. Review it. Always remember to review your notes after you take them and do the problems. All right. So that concludes our lesson. If you haven't already, please subscribe to my channel. Turn on your notifications. Let's get ready for some math videos. Great job.